Good afternoon. My name is Heather McCracken, and I'm with the Geodatabase Development Team here in Redlands, California. Joining me today is my colleague, Gary McDougall, who's also with the Geodatabase Development Team. We want to welcome you all to today's live training seminar, Introduction to Geodatabase Replication at ArcGIS 9.2. To begin, I'd like to briefly go over the topics that will be covered in today's session. I will start by exploring what geodatabase replication is, where I'll talk about some use cases for replication, and then discuss the 3 replica types available. Secondly, I'll cover the replica creation process. I'll then move on to talk about replica synchronization, and lastly, we'll discuss replica management. Throughout each topic, there will be software demonstrations, and at the end of each topic, there will be time for a review and Q&A. During development of geodatabase replication, the development team has strived to keep the following goals in focus. We wanted to build upon the disconnected editing functionality released at ArcGIS 8.3. We wanted to support more workflows for distributing data, and we wanted to include enhancements described by our disconnected editing users, such as allowing multiple data synchronizations without having to check out data each time, improve support for replicating relationship classes, better tools for describing replicas, and tools for working with schema changes. I will now outline what geodatabase replication is and what it allows us to do. Geodatabase replication allows us to distribute copies of our data to 2 or more geodatabases. You can edit these geodatabases independently and synchronize the changes when needed. Now let's consider some use cases for replication. You may have users that need to be disconnected from the network. So for example, you might have mobile users and field crews that need to be editing data while on site. They'll want to come back into the central database at the end of the day and synchronize their changes. Another use case may be when there's a need to maintain copies of data at different geographic facilities. In this case, you can make copies of your corporate data using replication and distribute your data to your regional offices. In some cases, users may need to maintain copies of data at different organizational levels. A good example of this is in the case of a government structure, where each level of government maintains their own data sets, and they share their data by synchronizing their changes between their geodatabases. Some users may want to maintain copies of data in both a production and a publication geodatabase. You have a production geodatabase where all your editors are doing their work and making their changes, and once those edits have been QA/QC'd, they are then sent to the publication geodatabase that is then used for printing maps or maybe publishing information on the internet. These are only a few case scenarios, but it might give you an idea of how replication can fit into your organization's workflow. Now let's move on to discuss geodatabase replication in a little more detail. The basic replication relationship is between 2 replicas, where the source of the data is the parent replica, and a child is then created from the parent. When you create a replica, you need 2 geodatabases. You start with one geodatabase that contains the data, and then you replicate to the second. In this diagram, the top geodatabase is the origin geodatabase, where all the data exists. When the replica is created, this database is labeled as the parent replica. The geodatabase at the bottom is the destination geodatabase, where the data is being replicated to, and this gets labeled as being the child replica. Together, they're known as a replica pair. Once the replica has been created, you can synchronize the changes between the 2 replica geodatabases. Replicas can be created from a specific version of your geodatabase. So you could choose to replicate the default version or any other named version in your geodatabase. You can also choose to replicate specific data sets within your geodatabase. You don't have to replicate your entire geodatabase. And then within each data set, you can specify a subset of features or records that you wish to replicate. Again, you don't have to replicate all features or records in your data sets. It's important to note that geodatabase replication is supported across database management systems. For example, you can replicate your data from a geodatabase that's hosted by a SQL Server database to a geodatabase that's hosted by Oracle or DB2. The geodatabases do not need to be supported by the same DBMS vendor. All replication workflows are supported on both local area networks and wide area networks. And when we're talking about the local area network, or LAN, we're talking about connections to your local geodatabases on your network. So for example, I have ArcSDE running on my network, and I can just connect to it directly through ArcCatalog. Or you can connect over the WAN, where you can use ArcGIS Server and Geodata Web Services to access remote geodatabases. So say I've got a geodatabase in Olympia, and I want to be able to create a replica from it off-site. What you can do is you can create a Geodata web service for this geodatabase, and then you can access it remotely via ArcGIS Server. All the tools and the wizards that we'll be using in our demonstration today can work equally well with Geodata web services, just as they do with your local connections. Now I'd like to introduce you to the 3 replication types. The first replication type we'll look at is checkout check-in replication. Checkout check-in replication allows you to replicate your data to a geodatabase, make edits, and then check the changes back into the parent replica one time. Once that check-in process is completed, you would need to create another checkout if you wanted to make additional changes. The next replica type is one-way replication. With one-way replication, you could replicate your data to a child geodatabase, and once the replica has been established, you can send the changes multiple times. However, one-way replication supports sending data changes from the parent to the child replica geodatabase only. And finally, we have two-way replication. This is similar to one-way replication, where you can send your changes as many times as you wish, but for two-way replicas, the data changes can be sent in either direction. So you can make edits on both geodatabases, and you can synchronize from the parent to the child or from the child to the parent as needed. Now let's take a closer look at each replica type. First, let's talk about checkout check-in replication. Checkout check-in is equivalent to disconnected editing, which was introduced at ArcGIS 8.3. So some of you will already be familiar with this replication type if you've already used disconnected editing in previous releases. All we've done is move it under the heading of Geodatabase Replication. As with all replication types, the parent replica geodatabase must be hosted by an ArcSDE geodatabase. You can then check out your data from your parent to your child geodatabase. For checkout replicas, the child replica can be hosted in either a personal geodatabaase, a file geodatabase, or any of our ArcSDE geodatabases. Once you've checked out your data, you can edit the child geodatabase, and when you're finished, you can synchronize your changes with the parent. This is also called check-in. Any edit conflicts between the geodatabase edits will be detected on check-in. Again, the one-way replication only supports one synchronization process. So once the child edits have been synced with the parent, the child geodatabase can no longer be used to check in further changes. If you want to make additional changes, you would need to create a new checkout replica. Our next replica type is one-way replication. One-way replication is used in situations where you want to send changes from the parent to the child replica only. For one-way replicas, both the parent and the child must be hosted in an ArcSDE geodatabase. One-way replication supports 2 model types, both full and simple. The full model type supports creating replicas with complex data types like geometric networks and topologies, and requires that the child data be versioned. With the simple model, the child replica's data is created as simple types and is not registered as versioned. Therefore, geometric networks or topologies from the source geodatabase are not created on the destination. Once a replica has been created, data changes can be sent multiple times from the parent replica to the child replica. In one-way replication, the child replica geodatabase is considered read-only. So if there are edits on your child geodatabase that conflict with those on the parents, they won't be detected at synchronized time, and they will be overwritten on the child geodatabase. A good example use case scenario for one-way replication is a publication geodatabase example. Suppose you have a read-only publication geodatabase that's being used to serve data on the internet. Data is not being edited in this publication geodatabase. You have a second geodatabase, your production geodatabase, where all the edits are taking place. You can use one-way replication to periodically synchronize your updates from the production to the publication geodatabase. The last replica type is two-way replication. Two-way replication is used when you want to synchronize changes from both the parent and the child replica geodatabases. For two-way replication, both the parent and the child replicas must be hosted in an ArcSDE geodatabase. Two-way replication allows data changes to be sent multiple times in either direction. So again, you can send changes from the parent to the child, from the child to the parent, or in both directions within the same operation. If the same row is edited in both replica geodatabases, it will be detected as a conflict when the replicas are synchronized. Reconcile policies are provided at synchronization time to define how the conflicts will be processed. And we'll take a closer look at this when we discuss replica synchronization. Okay, let's move on to our first software demonstration, where I want to show you replication in action. Let's imagine that we're part of a utilities field crew that's working for the city of Riverside. We have already created our two-way replica from a subset of data that exists on our enterprise geodatabase. And we've replicated this to our field laptop, which is running ArcSDE Personal. As a result, we've been able to take our data out into the field with us, make our edits while we're on site, and then imagine that we've come in at the end of the day and we want to synchronize our changes with our enterprise geodatabase. Now, I'm just going to point out here that for the purposes of this demo, both the enterprise and the field geodatabase are on the same SQL Express database, but imagine that your enterprise is actually a full-blown, let's say, SQL Server running enterprise SDE. So in order to synchronize, you can right-click either connection to your field geodatabase or your enterprise and access the Distributed Geodatabase tools and click the Synchronize Changes command. But before I go through this wizard with you, I want to show you the changes that we'll be synchronizing. First, we'll take a look at our enterprise geodatabase. While the field workers have been out, we have digitized 3 new building footprints on the enterprise geodatabase. You can see them right here. I'll switch over to our field laptop, and you can see that those building footprints do not currently exist on our field database. But what we do see is some new service lines and meters that have been added to the field geodatabase. So we want to synchronize the changes so that both edits can be seen in both databases. I'm going to go back to catalog and again look at my synchronize changes wizard. This wizard lets me specify the 2 geodatabases that I want to synchronize. So I've got my field geodatabase and my enterprise geodatabase. And I have a list of replicas that exist between the 2. I'm going to synchronize rep demo, which is my only replica. And I'm going to choose to send the changes in both directions. This next panel allows me to specify some settings about conflicts. And this is something we'll talk about when we discuss replica synchronization. I'm just going to accept the defaults, click Finish, and you'll see we have a progress dialog here showing us that our data changes are being sent from the parent to the field geodatabase and also from the field back to the parent or the enterprise geodatabase. Let's go back and take a look at our map documents, and I'm just going to refresh my version, my connection to the version on my enterprise database. And what we're looking for here is the appearance of those secondaries that were added in the field. We'll refresh, and you can see that those have come in. They now exist as features in our enterprise database. Likewise, let's go to the field geodatabase. I'm going to refresh, and what we're looking for are those new building footprints to come in. I'll refresh, and there they are. We've successfully synchronized our changes with our enterprise database. Now let's take some time to review what we've discussed thus far. Geodatabase replication allows us to create copies of our data and synchronize our changes between two or more geodatabases. We've talked about some use cases for replication, and we've also introduced the 3 different replication types: checkout, check-in, one-way, and two-way replication. I'm now going to turn it over to Gary to answer some of your questions that have come in.
Thanks, Heather. Matt from Inglewood asks, is it possible to replicate non-SDE tables using geodatabase replication at 9.2? And the answer is no. You need to have your tables registered with the geodatabase and versioned, and have global IDs added for one-way and two-way replication if you want to have your tables involved in geodatabase replication. We do have some extensibility objects that you can use to do some post-processing. So say, for example, you run the create replica command, you can write an application to listen to some events that then go in and do additional custom work that you define. Gary from Port Hueneme asks, if both databases in a replica pair use direct connects, will the replication still work? The answer is yes. You just need an SDE connection. Since geodatabase replication is built on top of the geodatabase, the only requirement is that you be able to connect to the geodatabase. So all of those connection options are available. Doug from Norcross asks, can you replicate from SQL to Access? The answer is yes for checkout, check-in replicas. For the other types of replicas, one-way replication and two-way replication, you need an ArcSDE geodatabase on both ends, and since Access doesn't support that, it wouldn't work in that case. Bill from New York asks, can you automate the replication process? The answer is yes, and the way you do that is by using geoprocessing tools. So you can create a model with some replication geoprocessing tools, and then export those out to Python, attach those to the Windows scheduler, and then run them at regular intervals. Heather will show a demo of this later on in the presentation. Brian from Houston asks, are there performance advantages of one type of replication over the other? Well, the answer to this question is yes, there are performance advantages. And the reason why is because some types of replication require less processing. For example, two-way replication allows you to sync in from both the parent of the child and from the child of the parent. However, one-way replication only allows you to sync from the parent of the child. As a result, less work is required for us to process the synchronization. So we don't have to worry about needing to send back from the child to the parent, and therefore, in general, performance is better. When considering the type of replication to use, I recommend reading the online docs. We step you through the different requirements and the advantages and disadvantages of each replica type. And from there, you can make your decision. Now I'll hand it back to Heather to continue the presentation.
Thanks, Gary. Now we're going to continue on and take a look at our second topic, replica creation. Our first step in the replica creation process is to choose which replica type or types that will work for your workflow. We have discussed the 3 replica types that are available: checkout, check-in, one-way, and two-way replicas. Before choosing, we would recommend that you have a good understanding of the 3 replica types. You may wish to review the detailed documentation on each type before deciding which replica types fit best into your business workflow and suit your user requirements. At the end of our presentation, we will provide some additional resources that will help you determine which types of replica will work for you. Now let's discuss the different tools that we have available to use when creating replicas. First, we have the Create Replica Wizard. This wizard is accessible from the Distributed Geodatabase toolbar available in ArcMap. The wizard supports a range of default and advanced replication options that will allow you to customize the replica you're creating. The Create Replica Wizard is our recommended way to create your replicas because of these advanced options it offers. And during our next software demonstration, I'll be showing you the Create Replica Wizard and some of these options. The next set of tools available to you are the Create Replica and Create Replica from Server geoprocessing tools. You can find these tools by navigating to the Data Management tools in our toolbox and expanding the Distributed Geodatabase toolset. You'll also notice that we have geoprocessing tools for our other geodatabase replication tasks, such as synchronization. Geoprocessing tools provide you with the added functionality of being able to automate your replication tasks. For example, you could build your own custom models or even create scripts that can be run in the Windows scheduler. Our last way to create replicas is through using the ArcObjects API. The ArcObjects API is available to support writing code to create replicas. You can apply complex criteria and extend replica creation. You can use ArcObjects to customize any geodatabase replication task. Details about each of these tools that we've talked about can be found in the ArcGIS 9.2 Desktop Help online documentation. Before you create your replica, you must ensure that the data meets the following requirements. First, you must be connected as a user that has write access to the data. All the data must be registered as versioned in your ArcSDE geodatabase. And please note that geodatabase replication requires the full versioned architecture. So the new functionality of versioning your data with the option to move edits to base is not supported with geodatabase replication. Again, it must be fully versioned. For one-way and two-way replication, there are two additional requirements to successfully replicate your data. You must add global IDs to all of your data sets, and we also require that all data is stored in a high-precision spatial reference. And all of these tasks can be completed off the context menu of the data sets in our catalog. Now that our data has met these requirements, the next step is to define the data to replicate. Replica creation determines the data to replicate using two different mechanisms: filters and relationship classes. There are three types of filters that can be applied during replica creation. First, we have the spatial filter, where a geometry of a defined area can be used to determine the data to replicate. So for example, if you're replicating an ArcMap, the spatial filter is determined by the current view extent of the map document, or you could use the boundary of a selected graphic. The second filter type is using selections, where the replicated data can be based on selection sets defined for the individual feature classes and tables. The last filter type we have is definition queries, where any definition queries applied to individual feature classes and tables can determine the data to be replicated. If you have more than one of these filters applied, the intersection of all of them is used. Once data has been added to the replica by processing these filters, the relationship class logic is applied. This logic looks at the rows that are already being replicated based on your filters to see if they're related to any other rows in your geodatabase. If they are, these additional rows will also be replicated. So in my diagram here, I have a parcels feature class. This parcels feature class is related to the owners 1 table through a relationship class called R1. And this owners 1 table is then related to another table, owners 2, through a second relationship class, R2. Imagine that you have your parcels feature class in your map document. You've zoomed to the extent that you want to replicate. And what we do is we look to see if any of those parcels in your replica area are related to records in the owners table. If they are, we replicate those. As well, we look to see if those records in the owners table are then related to records in the owners 2 table. And if they are, those will get replicated as well. Okay, now it's time to move on to our second demonstration, replica creation. For this demonstration, I want to take you a step back and show you how to create the replica that we were using in the first demonstration where we were already synchronizing. Again, let's imagine that we're working as part of a utilities field crew working in the city of Riverside. We're going to be working out on site for a few weeks, and we want to be able to take our data out onto our field laptop. We want to be able to make edits in the field and come in at the end of the day and synchronize our changes with our central database. What we're looking at here in our ArcMap document is utilities data for the city of Riverside. This data is stored on an enterprise SDE geodatabase in our central office. This is going to be our parent replica. And we're going to create our replica to our field laptop, which is running on personal SDE. I'm going to go to a bookmark that I have of the area that I want to replicate. And the area that I want to replicate is a particular city block that's defined with this green graphic. Now, if you'll remember from my slides, I discussed using a spatial filter to define the data that you want to replicate. And that's what I'm going to do. I'm going to select this graphic and use this graphic as the spatial filter for my replica. I'm going to open up the Create Replica Wizard, which is on the Distributed Geodatabase toolbar. And this first panel asks me the type of replica that I'd like to create. I'm going to specify to create a two-way replica because I want to send changes from my field laptop geodatabase to my enterprise. I'm going to navigate to my field database because this is the geodatabase I want to replicate to. And I'm going to name my replica. And I'm just going to call it Rep Demo. I'm going to check to show the advanced options in this wizard. But again, we're just going to keep the defaults. But I do want to discuss some of these advanced options with you. This next panel gives us the opportunity to specify the spatial extent of our replica. Because we have a graphic selected in the map, the default is to use that boundary of the currently selected graphic. Alternatively, you could choose the current display extent, the full extent of the data, or specify a particular envelope. You also have the ability to explicitly exclude or include any of the feature classes and tables in your map. You can choose to replicate the features or just schema only. And you also have the ability to choose to apply the spatial extent to any of your feature classes. This last option is about replicating your related data. By default, we do process the relationship classes, but if you would not like this to happen, you can simply uncheck this option. Our next panel talks about which replica, either the parent or the child, will be the initial data sender. And this is not something we need to be concerned with when we're working in a connected environment, but we'll talk about this in a little more detail when we talk about replica synchronization. I'm just going to accept the defaults of the child being the initial data sender. This next panel allows us to specify key configuration keywords for our child geodatabases. And this last panel lets us specify post-create replica options. We can choose to change the layers in the map document to point to our checked out data on our field laptop. And we can also choose to save a map document that also points to this checked out data. And this is a great option if you want to keep the symbology that you specified on your enterprise geodatabase. We're just going to keep the defaults and click Finish. And you'll see our progress dialog showing you what's happening. First, we extract the schema for the data we're replicating. Then we're going to extract the data itself. We'll then look for any related objects. And lastly, we're going to register the replica with the workspace. Okay, this is completed, and I've already created a map document that points to the data on the field laptop. I'm just going to open up this map document now. And you'll see, so this is looking at the field laptop, that only the features that were either completely within this green graphic or that intersected this graphic were replicated. So you'll notice the features outside of that graphic were not replicated. Another way we can tell that the replica was successfully created is by looking at our Replica Manager. And this is also another utility that's available off the Distributed Geodatabase toolbar. This utility lists all the replicas in your workspace. So for our field laptop, we have just the one, Rep Demo, which we just created, and it lists various properties about it. It's a two-way replica, and it's a child replica geodatabase. Let's go back and take a look at our enterprise database. We can open up the Replica Manager for this as well and see that same replica listed, but this time it's listed with a role of type parent. Okay, let's do a quick review. We've talked about how you choose your replica types that are going to work for your organizational workflow. We discussed some tools to help you create your replicas. We've talked about preparing your data for replication, and also that Geodatabase Replication use filters and relationship classes to determine the data to replicate. I'm now going to pass it over to Gary to answer some of your questions that have come in throughout the broadcast.
Thanks, Heather. Tim from Sydney asks, excuse me, is checkout available with an ArcView license? And the answer is yes. You can, well, not yes completely. You can use checkout with an ArcView license to edit the checkout database. In order to create the checkout, however, you need to have an Arc Editor or greater license. So if you have simple data with an Arc Editor or greater license, you can create the checkout, and then once it's checked out, you can edit the data with your ArcView license, and say, for example, in the field, then take it back in and check it in. When you go to check in, again, you need that Arc Editor license. Michelle from Alameda asks, can you do one-way replication to several child DBs at once? And the answer is yes. You can have a single geodatabase that hosts multiple parent replicas, and each of those parent replicas can go to a different child geodatabase. Okay, Michael from Seattle asks, can replication be run as an unattended scheduled job, for example, at night? The answer is yes. What you can do is you can create a model and then export that model out to a Python script, and then have that script attached to your Windows scheduler, and then set to run whenever you wish to have it run. Okay, Kevin from Sacramento asks, can I still use my pre-9.2 checkout and check-in applications with ArcGIS 9.2? The answer is yes. Because we fully support the fully backward support previous applications, you can do this. We still have the same geoprocessing tools, so all your geoprocessing models will work. We also have the same ArcObjects API still supported at 9.2. Where things are different is the user interface. We've changed the user interface, added more commands, and changed some of the commands. But all of that same functionality is still there at 9.2. There's a help topic that you can read that will outline the changes and differences and map the 9.2 functionality to the pre-9.2 functionality. Okay, Steve from Portland asks, how do I add global IDs to my data? Well, there are several ways that this can be done. You can either use a command within our catalog, which allows you to add global IDs at the feature class, table, and feature dataset level. And you can also use a geoprocessing tool for adding global IDs. Okay, with that, I'll hand things back to Heather to continue with the presentation.
Thanks, Gary. Now that we've gone through creating our replicas, let's talk in more detail about replica synchronization. Replica synchronization is a process that allows you to apply your data changes across your replica geodatabases. Replicas can be synchronized in either a single direction or in both directions. So recall that checkout, check-in, and one-way replicas are synchronized in a single direction, but two ways can be synchronized in either a single or in both directions. Replica synchronization is based on exchanging messages between the parent and child replicas, and it is fault tolerant. Synchronization uses versioning. So replication is built on the versioning technology, and the synchronization process involves creating hidden system versions. Replication uses these system versions to determine what data changes to send and what to receive. There are two different modes in which you can synchronize your replicas. There is connected synchronization and disconnected synchronization. With connected synchronization, the replica geodatabases are connected by computer networks through either a local area network or a wide area network. So you can connect your geodatabases through local connections, or you can use ArcGIS Server and Geodata Web Services to access remote geodatabases. Being connected can mean that the geodatabases are accessible on the network at all times, or only intermittently. An example of being intermittently connected is a field worker example. When you're out in the field, you are not connected, but when you come back into your office at the end of the day to synchronize, you are connected. With disconnected synchronization, the geodatabases are not on the same network at synchronization time. In this case, updates are synchronized by exchanging messages between the replicas. These operations are performed by the end user and done by exporting files from one replica, transferring these files to the other replica, and then imported. These next slides will go through some synchronization examples for a two-way replica. When you synchronize your replicas in a connected environment, you can connect to both replica geodatabases directly and simply choose which replica you'd like to synchronize. And we saw this in our first demonstration. All the required message exchange to complete the synchronization is managed by the system. Connected synchronization also allows you to choose the direction in which your changes will be sent. This diagram here shows sending data changes in both directions within a single operation, from the geodatabase to the right, to the geodatabase on the left, and the opposite direction. You'll notice that on this diagram, I haven't labeled which replica is the parent and which is the child. This is because once you establish your two-way replica, it really doesn't matter which is the parent or the child. They can both equally send data changes to the other. Okay, now that we've talked about how to synchronize in a connected environment, let's do the same workflow in a disconnected environment. Remember, for disconnected synchronization, the end user is responsible for message exchange. So for our illustration here, we're showing our data sender sending data changes to our data receiver through using file transfer. So the data changes are exported to a file. This file can be either XML, a Delta personal geodatabase, or a Delta file geodatabase. Once the file has been exported, it can then be transferred to the relative replica. And this can be done, say you could burn the file to a CD and send it through the post, or perhaps send it through email. Once it's received by the relative replica, it's then imported. Next, the data receiver exports an acknowledgement file, which is then transferred in a similar manner to the data sender. This acknowledgement message lets the data sender know that its changes were successfully received by the data receiver. And you can see that the data change direction is the exact same for our disconnected synchronization as it is with our connected synchronization. It's just that the message exchange is handled by the user. Now I'd like to discuss synchronization and conflict detection. During synchronization, if there are edit conflicts, a reconcile policy is used to determine how to handle those conflicts. There are 3 reconcile policies to choose from. In favor of the parent, where if an edit conflict occurs, the edit from the parent geodatabase are automatically applied. Next, we have in favor of the child, where any edits from the child geodatabase are automatically applied if there is a conflict. And lastly, we have our manual reconcile policy, where if a conflict occurs, the replica will be marked as in conflict. And we allow you to manually go in and resolve those conflicts on a case-by-case basis. And you can do this through using our standard conflict resolution dialog that's available with your regular versioning workflows. You can manually reconcile and post the synchronization version with the replica version. And once this rec and post has been applied to the replica version, the replica will no longer be in conflict. So again, the first 2 choices, in favor of the parent or in favor of the child, automatically resolve any conflicts, while the third choice is to manually resolve those conflicts in an edit session. And it's up to you for however it works best for your workflow. Replica synchronization also allows you to specify whether conflicts will be defined by object or by attribute. When choosing to define conflicts by object, conflicts are detected when any edit to the same feature is applied in both replica geodatabases. So for example, on the parent geodatabase, I might move a feature. And then on the child geodatabase, I may make a change to a non-spatial attribute of the same feature. So say I change the name of the object. If you define your conflicts by object, this will be considered a conflict. But you can also choose to define your conflicts by attribute, where conflicts are only detected when the same attribute of a feature is edited in both replica geodatabases. Let's move on to our next software demonstration, where I'll show you replica synchronization. Now we're looking again at the same replica that we've been working with throughout our demonstrations. And since we've created the replica, we've made some more edits. I'm going to edit some features on the enterprise database I'm going to digitize some new building footprints. I'm going to save my edits. And now let's go over to the field database. The field workers have added some meters and some service lines to those original building footprints we received in the first demonstration. We'll add some secondaries here. And once we're finished, we've come back in at the end of the day again, and we want to synchronize our changes with our enterprise database. And what I showed you in our first demonstration was using the synchronize changes command, which is available also in ArcMap. But what we want to do is automate our workflow. And a great way to do this is using our geoprocessing tools. You can find our geoprocessing tools in the data management tools. We'll just expand this and look at our distributed geodatabase tool set. And here you'll see that we have a whole host of geoprocessing tools for performing your replication tasks, like adding global IDs, creating your replicas, and synchronizing your changes in both the connected and disconnected environment. What I've done before this demonstration is I've actually created a model that synchronizes the data changes between the field and the enterprise database. So I'm going to open it up here, and all I've done is I've added the synchronize changes command to this model, and I've specified the parameters that I'm going to want to use with each synchronization. So I've specified the two geodatabases that I want to synchronize, my enterprise and my field. I've specified the replica name, and I've specified the directions. I want data changes to go in both directions. I've also specified my conflict resolution policy to be in favor of Geodatabase 1, which is our enterprise database. And I've also said I want to define my conflicts by object. And you can define these parameters however works for you, and these will be saved in your model. Now, what I can do is I can run this model directly from my geoprocessing tools, and that's what I'll do right now. You can see that our progress dialog is showing us that synchronization is happening and the data changes are occurring. So this is great. We've just automated our workflow somewhat because we've been able to specify the parameters that we want to use with each synchronization. But what we really want to do is automate this completely so that there's no user interaction. And this goes to one of the questions that was brought up in the last Q&A session. You can export your model to a script, which you can then run in the Windows scheduler. And the way you do this is click the model menu, go to export, script, and you can see here you can export your model to either a Python script, a JavaScript, or a VB script. Once it has been exported, you can then just add it to your standard scheduled tasks, which come with your operating system. It's just located in your system tools. So all I did here was I just added a scheduled task. I navigated to my script, and I specified that I want this synchronization to happen every night at midnight. So it doesn't require any user clicking any buttons. All you have to do is come in, connect to the network, and this synchronization will happen automatically without, again, any user interaction. So this is a great way to completely automate your workflow. Now let's take a look and make sure that our data changes were received. We're looking again at the field laptop, and so remember that we digitized some new building footprints on the enterprise, and I'm just going to refresh my connection to the version. And you'll see that those buildings have now come into my field geodatabase. Let's go look at our enterprise, and you'll notice that those meters that we added on our enterprise, that's what we're looking to come in here. I'll just refresh my connection to the version, and you'll see that those changes have come in. So again, the point I want to drive home here, that you can manually interact to synchronize your replicas, but we do offer the ability to automate your workflows through either using custom tools, which we ran here, but you can also completely automate this workflow by setting up your script to run in a Windows scheduler. Okay, review of what we talked about so far. We've talked about replica synchronization in both a connected and a disconnected environment. I went through some synchronization examples with you for two-way replicas. And we also discussed the three different replica reconcile policies in favor of the parent, in favor of the child, and the manual reconcile policy. And we also talked about defining your conflicts by object or by attribute. I'm going to pass it over to Gary now to answer some more of your questions.
Thanks, Heather. Jim from Salinas asks, can you add feature classes to your replica database after initial creation? The answer is yes. We have some APIs available to add those feature classes to your replica once it's been created. The feature classes must be simple, and this can only be done with code. Jim from Salinas also asks, is related data replicated if a relate is defined in the ArcMap session, or only if a relationship class is in place? The answer is only if a relationship class is in place. Relates and ArcMap are only relevant to that ArcMap session, so it has to be a persistent type of relationship, like a relationship class. Rich from Fort Collins asks, can you replicate between two databases inside a single Oracle instance? With geodatabase replication, we require two separate geodatabases for replica creation. So if you can set up your environment such that each database from the Oracle instance points to a separate ArcSDE instance, which would be two separate geodatabases, then this should be possible. Jason from Halifax asks, what if the schemas change in the replica geodatabases? With geodatabase replication, we are fault tolerant. That means that if things change, such as schemas, or if the system crashes, then we can recover. So we can recover, or we just apply what we can. So, for example, say I add a column to my my feature class, and then I synchronize changes. Well, it'll only synchronize what it can. So if it doesn't have any information for that additional column, those changes won't be synchronized. Another example is if partway through my synchronization, the system crashes. What happens? Well, everything is done inside a transaction. So if the system crashes, nothing gets committed, and the databases are rolled back to their previous state. So when the system gets recovered, you can then go in, run the process again, and it's at the same point you were at when you started. Mary from Los Angeles asks, can I use both connected and disconnected synchronization with the same replica? Sometimes connected, sometimes not. The answer is yes. Synchronizations, whether it be connected or not connected, will both work. So you can sometimes do connected, sometimes do disconnected. That's fully supported. And now I'll hand it back to Heather to continue the presentation.
Thanks, Gary. Finally, I'd like to briefly touch on replica management. ArcGIS provides tools to help manage your replicas. We've got tools for replica description and viewing, and also tools for working with schema changes. I'll start first with the Replica Manager, and I showed this tool to you briefly in our replica creation demonstration. With this utility, you can list all the replicas in your geodatabase, you can rename, refresh, and review all the properties of each replica, and you can also choose to interact with this utility so that you only view, say, replicas with a role of type parent, or maybe just list the checkout replicas in your workspace. You also have the ability to access what we call a replica log. By right-clicking on a particular replica, you can bring up this log, and it will list all our synchronization events that have happened for a particular replica. This utility is available in both our catalog and in ArcMap. Next, we have the Create Replica Footprint command. This allows you to export the contents of your Replica Manager to a feature class. Each feature in the feature class represents the spatial extent of a replica in your workspace. So the geometry of each feature is the spatial filter that had been defined for the replica. And attributes for the feature class store the information recorded in the Replica Manager. Replica Footprints feature class functions as a helpful administrative tool where you can query for information. So for example, you could find all the replicas waiting to receive messages, or you could determine if any of your replicas are in conflict, or you can query for all the replicas owned by a particular user. So it's a great way to see the status of the replicas in your workplace. The next tools I want to talk about are tools for working with schema changes. Over time, schemas may change on the Replica geodatabases, and replication is designed to be tolerant of most of these schema changes. For example, if a field has been dropped, let's say, on one Replica geodatabase, the synchronization will just simply skip that field and complete the rest of the data changes successfully. But there may be a point in time where you wish to apply schema changes across your geodatabases, and ArcGIS provides you tools to do so. Schema synchronization is done in two separate processes. First, you need to compare your replica schemas to determine the differences. And the result of this comparison is a schema changes file. The next step is to import these changes to the Replica geodatabase. The schema differences will be listed, and you can choose whether or not to apply these schema changes. So lastly, we've talked about tools to help you manage your replicas. We talked about the Replica Manager, which again I showed you in the first demonstration. We talked about the Create Replica Footprints command, and we also talked about tools to help you work with schema changes. I'm going to pass it over to Gary one last time to answer some of your questions.
Thanks, Heather. Baird from Denver asks, do all users have to be logged off the system for replication to work? Currently, that's usually recommended for Compress to do all that it's expected to do. And the answer is no. When you're synchronizing changes, it's like another user on the system performing edits. So other users don't have to be logged off the system to do synchronizations associated with replication. Baird from Denver also asks, the Reconcile policies refer to parent and children. Is this only for one-way replication, or does it apply to two-way? The Reconcile policies actually only apply to two-way replication and check-out, check-in replication. Since with one-way replication, when synchronizations are performed, changes are applied directly, there is no reconcile that happens during the synchronization, so those policies don't apply. Don from Irvine asks, if I'm using disconnected synchronization, what happens if one of the messages gets lost? And the answer is that all you need to do in that situation is resend your changes again. You just need to export and resend. The system is designed to detect if the previously sent set of changes have had acknowledgments come back. And if they haven't, it just simply resends them again. Matt from San Diego asks, what types of schema changes are supported? Well, we do support a limited set of schema changes, but we don't support every type of schema change. The schema changes that we support include adding and dropping fields, adding and dropping domains, as well as dropping topologies and geometric networks. For a complete list of all the different types of schema changes that we support, I suggest referring to the online help. And the final question I'll take from Tanya from Seattle is, how does geodatabase replication work with history? Well, geodatabase replication is independent of history. You can enable history on your replicated data and have it update when synchronizing if the replica is based on the default version. One thing to keep in mind is that the dates stored on the replica receiving the changes correspond to the time of synchronization, not the time when the data was archived on the relative replica. And with that, I'll hand things back to Heather to finish up.
Thanks, Gary. It looks like we're out of time, but before we go, I'd like to point you to a few more resources. We have some instructor-led training, as well as the ArcGIS 9.2 desktop help, which we referred to throughout the seminar. We also have our ArcGIS Server 9.2 help, which can help you understand a little bit more about what ArcGIS Server has to offer. And we also have some white papers that are in progress, so keep your eyes out for those. Your comments help us improve our seminars. Please take a moment to complete our survey. Just click the Give Us Feedback link to take the survey. We hope you've enjoyed today's seminar, and on behalf of ESRI, I'd like to thank you all for attending.